Testing, testing. If you don't hate threading dial indicators, there's a good chance you've probably never had to deal with one. Of course, they can be fairly useful. How else would you know when it's time to jerk the lever, clamping down on your half nut? But let's not forget, the toil in timing and terror in terminating these moments of mechanical harmony are inevitabilities when it comes to thread cutting, at least on any ordinary lathe. But this lathe, being a little less than ordinary, has a brain. And today, we're teaching it to think. Now, it's probably pretty clear by this stage that I'm not an engineer, and especially when it comes to software and electronics, I'm completely out of my depth. Just like you might be if you missed the last video, where I sent the change gears on my lathe packing, replacing them with an encoder, a motor, and a dash or two of control logic. I'll be honest, by this stage, I was definitely wishing I'd taken on a slightly simpler project, like, I don't know, hot gluing a razor blade to a piece of all thread, or even just bashing two rocks together. But the temptation of an automatic nut button and the convenience that came along with it was too much to resist. You and I both know there has to be some way to calculate the exact moment to re-engage the lead screw based on the angle of the spindle relative to the lead screw position. Unfortunately, it didn't seem to matter how long I spent staring at the lathe with a blank look on my face, occasionally fiddling with the half nut lever. I just couldn't, for the life of me, figure out what it could be. Okay, so I wasn't just staring at the lathe with a blank look on my face the whole time, or even most of the time. You see, I'd been working on the code in my office with its comfy chair, multiple screens, and proximity to the kettle, which meant that every time I wanted to test a small change, I was looking at a 10, maybe 20-second power walk to the shed. And believe me when I tell you there were a lot of small changes. I've been meaning to put together a mock-up lathe I could use for bench testing the Spaghettitronics in my office ever since I installed the original version on the real lathe 5 weeks ago. But between all those trips to and from the shed, and from and to the shed, I just couldn't seem to find the time. Does anyone else feel like their life is just an endless chain of projects, each undertaken with the goal of solving some minor inconvenience encountered during the attempted completion of its precursor? I can't be the only one, thankfully. While giving my patrons a sneak peek of the almost finished project, I remembered to ask if anyone had any insight on my spindle synchronization issues, and while I didn't get the exact formula I was hoping for, I did get a bunch of helpful tips, as well as the offer of a helping hand from one particular patron, Jack. Like me, Jack is also currently trying to pretend that spending hundreds of hours upgrading his less than perfect lathe,
you want to have as much stiffness as possible,
is totally worth it, with the added bonus of actually knowing how you're meant to write software.
You know, like those McDonald's alarm systems?
Yep.
I actually like the first
Sick.
version of that. Yeah.
Bastard.
I didn't do the sounds.
Okay.
Yeah.
Which, if it wasn't already abundantly clear, makes him the perfect accomplice for this project. Within a couple of days, Jack had taken my kindergarten level Crayola code and somehow transformed it into a curated collection of classes and configuration files. And I, spurred on at last by the frenzy of an extrinsic motivation, finally got around to knocking up not 1, not 3, not 10, but 2 test rigs. Now, I know they're not perfect reproductions of the real lathe, but I didn't have any fuchsia on hand, and I've really been trying to curb my filament hoarding habits. Besides, it didn't need to be fancy, it just needed to roughly simulate the position of a spindle and a lead screw, and it did that, well, adequately. So please, don't use the affiliate link in the description for all your Bamboo Lab purchases. It only serves to enable more printing, more projects, and more piss takes. Once Jack and I were properly equipped, things were progressing at the speed of time, and before too long, Jack had implemented a host of improvements. My bloated interrupts were cut back to the bare minimum, the esoteric Bresenham loop became obsolete in the wake of a new pulse generator employing the purportedly perplexing power of the floating point, and jogging had finally arrived, in the basic form of 1 thread pitch at a time. Even if none of that means anything to you, you might be getting the impression that this was the point where everything clicked. Jack had done some amazing work, and all of these changes were completely sensible. There was no doubt they were going to make future development a whole lot easier. But there's no escaping the simple, well-established, irrefutable fact that I'm not an engineer, and I was already having enough trouble keeping track of my own changes, let alone helping to fix bugs. It was kind of like trying to solve a Rubik's Cube, and you've got this unshakable feeling of being watched. And your hands are mannequin hands. And the cube's made of jelly.
Oh, and the sky is red.
And you haven't liked the video and subscribed to Not an Engineer. Except, nowhere near as bad as that. Mind you, there's always a chance for any project to devolve into Kafka-esque nightmare territory, especially when you're juggling a whole bunch of them at once. I decided to roll back a few versions and try to tackle the problem on my own. And just like that, I was back to staring blankly at the lathe. Okay, so that was a joke. But the reality of the situation was far less entertaining. Even with my new handy dandy test rig and a couple of golden nuggets I'd picked up from Jack along the way, my spindle and lead screw remained decidedly unsynced, and my digital half nut entirely unengaged. Then, out of nowhere, a completely original thought. Maybe AI could be useful for things other than just this old Tony smut pieces. In fact, it does a pretty good job of writing code, with some help. It had been weeks, with what felt like next to no practical progress. But with a few hours of back and forth, I finally had 50% of the feature of my dreams. An automatic nut. So holding the sync button now sets the end point of a thread, zeroing out the spindle and lead screw positions behind the scenes. Then, I can jog to the position I'd like the thread to begin and press sync again, setting the starting location. Once that's done, pressing sync again will move between those start and end points, allowing me to make sure everything looks good. And once I'm instilled with a false sense of confidence, I can move the tool in at the start point, hit the nut button, and let the lathe take care of the rest. It'll automatically wait for the perfect moment to start feeding and know exactly when to stop. Then I can jog back to the start point and do it all over again until I've taken off too much material. What a perfect outcome. Completely free of any kind of plot device, including, but not limited to, twists, red herrings, or foreshadowing, wouldn't you say? I still wasn't satisfied. The beating heart at the center of the whole system, the little stepper motor that could, was right on the edge of full-blown cardiac arrest. I hadn't included any kind of acceleration logic in the code, because I'm lazy, but also because in my original conceptualization, it was essentially just a set of electronic change gears, always moving with the spindle. So it only ever needed to accelerate as quickly as the spindle itself. But with the addition of the automatic half nut, and its demands of instantaneous change in speed, even ignoring the regularity at which the motor outright refused to comply, the hammering noise coming from the gearbox was more than protest enough to make me reconsider my approach. While I definitely could have solved the instantaneous velocity issue with some more clever coding, by this stage I had nothing left in the tank as far as teaching transistors to think was concerned, and the fact remained that I'd never get the high-speed performance I was hoping for from this particular motor. A larger stepper motor might have been an option here, but that would do nothing to solve the issue of acceleration, while also creating a whole host of other problems in relation to just fitting the damn thing. So instead, I went with the cheapest 600 watt AC servo I could find. Conveniently, the faceplate of the new motor was almost identical to the old. All I had to do was open up the center hole a little and it popped right into place. With a few parameter changes and a touch of soldering, I had the servo drive accepting the same pulse and direction signals as its stepper predecessor, and with its almost constant 2 Newton meters of torque all the way up to 3000 RPM, the chances of encountering any kind of stall condition were completely eclipsed by the likelihood of the obviously and overwhelmingly undersized belt skipping teeth. On top of that, the new motor and drive combination did a far better job of smoothing out the sudden inundation of movement instructions internally, tidily excusing me from further struggle at the hands of C++, at least for now. But it wasn't all sunshine and reamers, because the whole time I'd been testing the new motor out, I'd been operating under the assumption that, with a bit of tuning, I'd be able to get rid of this 8 kHz whine constantly emitted by the motor while at rest. Of course, I soon found that assumption to be completely baseless. My best guess at the source of the noise was the ninth circle of hell. Second best was a constant overcorrection to the position of the motor owing to the insanely sensitive 17-bit encoder. Essentially a jitter between too far one way and too far the other. So I spent hours studying the manual, searching for some kind of position dead zone tolerance, There had to be a way to convince the thing that near enough is close enough, right? Well, make sure you let me know if you find it, because despite messing with absolutely every parameter at least twice, I couldn't even manage to make it a slightly less annoying frequency. At this point, it was really starting to feel like muttering to myself about Bresenham's line algorithm, floating point maths, PID tuning, and servo jitter while huddled in the corner of a damp room 50 years from now was becoming a very real possibility. And as nice as that sounds, this video wasn't going to edit itself, and I was really looking forward to eventually getting on with some other projects, preferably as dissimilar to this software-infused nightmare as possible. So, I cut my losses and switched back to the stepper. Yeah, it doesn't have the power to thread at 2000 RPM, but it also doesn't make me want to plug my ears with center drills. And the software, well, it works mostly. It might not be the grand, sweeping success I'd hoped for. Of course, at the same time I've been goofing around, Jack's been chipping away at a much improved version. So once I've recovered from my mild bout of software-induced burnout, I'll definitely be having a crack at understanding the work he's done, and so should you. You'll find a link to his channel in the description, and depending on when you're seeing this, all the source code. For now, here I am, with a lathe that's a little smarter, a lot more temperamental, and just barely functional enough to cut some threads without ever needing to touch another change gear again.
Oh, this is like some
Yes.
fever dream.
That's what the bit is.
Oh.
Tell me that's not the best Rubik's Cube made of jelly you've ever seen. This feels so fucking weird.